Hello, hello. So today we are talking about data transformations and how those transformations are going to change our SOCS. Remember, SOCS stands for shape, outliers, center, and spread. So we're going to see how transforming data impacts our SOCS. This goes with section 2.1 in your textbook. Please go there to follow along and to look at additional examples. So we're going to focus on this example. We're going to call this one the height example. So for the height example, it says the figure shows a dot plot of the height distribution for Miss Clayton's class, along with summary statistics from computer output. So you remember from in class, we've seen actually this exact diagram or this exact graph, but we also talked about this data that it gives me down here. This data is important because it has the mean, the standard deviation, and the 5-number summary given to us. So it looks a little different than stuff we may have seen in previous units, but all of the information is given to me, which is very helpful. So how we've used a table like this before is part A says Abby is 64 inches tall. What is her z-score? Well, we always annotate our problems, so 64 is my x. Sorry, that looks like x bar. Let me rewrite that. 64 is my x, so z equals x minus the mean divided by the standard deviation. Well, her x is 64 minus the mean of 67 divided by the standard deviation of 4.29. And when I do that arithmetic, I get negative 0.699. Well, we round z-scores 2 decimal places, so I'm going to rewrite this as negative 0.70. And this would be Abby's z-score. So this is review. We've seen this before. Well, now let's see how this data can be transformed. So part B of the same graph says Miss Clayton realized that all of the students had on shoes that were 1.2 inches tall. Therefore, she needs to subtract 1.2 inches from each height to figure out how tall each student truly is. So we have to subtract 1.2 inches from each of these data values. And I want to know how would that change the shape, center, and spread of the distribution. So take a minute to think about how would this graph change and how would these numbers change if each of these dots had 1.2 subtracted from it. Would it change the shape? Would it change the center, so where the graph is centered, if I shifted everything 1.2 down? And how would it change the spread? Would these points become further apart or closer together based on subtracting 1.2 inches? Well, this brings us to key point number 1. If we add or subtract a constant a, so if we add or subtract a number from each observation, then the center will increase by a. So the mean and the median are going to increase by that number a. Whatever I'm adding, they're going to increase by that amount. But the shape and the spread do not change. So this is the same problem we've been working with, but now I have space to write how the shape, center, and spread are going to compare with the original distribution. Well, we just saw in key point number 1 that the shape does not change. So I started with a unimodal and slightly skewed to the right graph. So it's going to stay unimodal and slightly skewed to the right. Well, now the center we just saw in key point number 1 is what changes. And it's going to change by whatever I added or subtracted. Since I subtracted 1.2 inches, my mean, which was 67, is going to get minus 1.2, or subtracted by 1.2, and that's going to give me a mean of 65.8. So my new mean is 65.8 inches. I subtracted 1.2 from the original mean. The median is also going to change. The median was 66. I'm going to subtract 1.2. So my new median is 64.8. I can even add a little context there and say inches. So I have my new median and my new mean. They both were subtracted by 1.2. I had 1.2 subtracted from them, sorry. Well, then the spread we saw does not change when I subtract a number. If everything shifts down 1.2, my range and my standard deviation are not going to change. So the standard deviation that was given to me was 4.29, and the range was from 60 to 75. Well, even though that now becomes 58.8 to 73.8, it's still a 15-inch range. Well, question C says, suppose that you convert the class's heights from inches to centimeters. That means I'm multiplying every value by 2.54. I want to talk about the effect that this will have on the shape, center, and spread. Well, if I think about multiplying each of these dots by 2.54, that's going to change a lot of things down here. My minimum and maximum are going to be much further apart. My spread, or my standard deviation, is going to change. And if I multiply each of these values by 2.54, they're going to change. So multiplying by a constant is going to change a lot of in my graph, which brings me to key point number 2. If we multiply or divide by a number b from each observation, so it's the same concept of doing something to each observation, but this time I'm multiplying. If I multiply by b, the center gets multiplied by b, the spread gets multiplied by b, but the overall shape does not change. If it starts out unimodal and skewed to the right, even if I multiply by a constant, the shape is not going to change. It's going to stay unimodal and skewed to the right. So if we talk about practically what this looks like, the shape we said stays the same. But the center, we said everything gets multiplied by whatever the multiple was. So it says multiply every value by 2.54. So my mean, which was 67, now gets multiplied by 2.54. And that gives me a new mean of 170.18. So this is 170.18 centimeters. Now, no more inches. I did a unit conversion. My median, which was 66, gets multiplied by 2.54. And that now gives me a median of 167.64 centimeters. So I can see right here, my mean and my median used to be only 1 point apart, but now they're almost 3 whole centimeters apart. So they were 1 inch apart, Now they're 3 centimeters apart, which is proof that my spread is going to change as well. So the standard deviation was 4.29. Well, it's going to get multiplied by 2.54. It's going to spread out the same amount as my multiple, and that's going to give me 10.897 centimeters is my standard deviation, and my range was 15, but it gets multiplied by 2.54, and that gives me a new range of 38.1 centimeters. So we can see the centers changed and the spreads changed as a result of multiplying by a value, we'll call that B. So these are our notes for today. These are our big foundational notes. Key point number 1, if I add a multiple, I only change the center. The shape and the spread do not change. But as we can see here, if I multiply by the value, the center and the spread are going to change. So that's a wrap. We can transform data by multiplying by a number B and or adding a constant A. We will look at many more practice problems in class to see this and also use our calculator to test our hypotheses. This goes along with section 2.1 in your textbook. Feel free to look there for additional examples and more practice problems. See you next time.